Okay, I just pressed admit all, so we'll let everyone join. Thank you for joining tonight, everyone, for AI in Action, how to create custom applications and data visualizations with John Racklin. We are so happy to have him here and you all here tonight. I'm going to hand it over to John to get us started. And please know that we're going to hold questions till the end. So John will let us know when it is that time, and we can use a combination of the Q&A option, or if you would like to leave a question in the chat, please make sure you use the hand function. Otherwise, I won't know to come to you. So once we do initiate Q&A, please just use the hand function. Handing it over to you, John.
Thank you, and good evening, everybody. It's a pleasure to be here. My name is John Racklin. I'm an associate teaching professor at Northeastern University. I'm actually based from my home here in Flagstaff, Arizona. I mainly teach online courses in software development, data science, computer science, some mathematics, and so on. And of course, machine learning and artificial intelligence. And tonight, I'm pleased to present to you my experiments in working with Claude AI over the last few weeks and to discover and learn how we can use Claude to develop custom applications and data visualizations. So I'll start my sharing my screen here and we'll get started. Let's see, is that showing?
Yes, we can see it.
Okay, terrific. Just by way of introduction here. So this is what we'll be doing tonight. I did want to say a few opening remarks about the nature of artificial intelligence and how it's making computer science more inclusive. AI really is for everyone. And then we'll dive right in. I've prepared a few case studies on using Claude to build data-driven dashboards. And these are going to be case studies using real data from the frontiers of science. These are not toy data sets. I really wanted to push Claude to its limits and see what it could do for us. And then afterwards, we'll have a Q&A. But as I said, you know, I really do believe that artificial intelligence is for everyone and that there is an urgent need now to really become AI literate in today's rapidly changing world. What does that ultimately mean? AI literacy is ultimately about understanding how we can use these tools effectively while at the same time appreciating their strengths and their limitations. And, you know, new developments in generative AI really are astonishing, but that sense of astonishment is something that we've experienced before throughout the history of artificial intelligence, throughout the history of robotics and computing. I just wanted to mention a couple of past historical events. In the 1939 World's Fair, Westinghouse presented Electro, the Moto Man, and it was a source of tremendous astonishment. It was basically an animatronic robot. And it would say things like, my brain is bigger than yours. And there was a presenter who would say things like, you see, all I need to do is speak into this phone and Electro does exactly what I tell him to do sometimes. That's actually maybe a pretty good description of how we in the modern world will begin to interact with Claude and other large language models. We simply declare what it is we want it to do, and usually it will do what we tell it to do. Sometimes we need to do some refinement, but generally speaking, it will do what we want it to do. And in the days of the ENIAC, the first programmable computer, this again created enormous astonishment. It was considered a mechanical brain enlarging man's horizons. And yet we know now that the ENIAC is far less powerful than a simple handheld calculator. And in 1997, when IBM's Deep Blue defeated world chess champion Garry Kasparov, it again created an enormous sense of astonishment and disbelief that a computer could do this. And yet, nowadays, we know that chess engines and the like are actually quite commonplace. And just FYI, there I am in the audience enjoying this tremendous spectacle. Okay, so I think that over time, as AI becomes increasingly infused into our society, that these will become more commonplace, and it will become clear to us how we can use these technologies to be more innovative, to be more creative, and ultimately more productive. Now, what we are not doing tonight is what I would consider traditional programming. And oh, by the way, Claude and many of these AI models can do programming. You could ask it to write a program, such as what I did here. I asked it to write a Python program to generate the first 25 prime numbers. It can do this with ease. We could copy and paste that code into an IDE and have it run, and it would produce a correct result. But that is not what we're doing here today. In fact, my assumption is that you don't necessarily have any background in computer programming, and that's just fine. That'll work for us perfectly well. What we are doing is something that has recently been termed vibe coding. And the idea here is that increasingly we think more about the what. What is it we want to be the outcome of our interactions with the AI? And we'll focus less specifically on the code that is being generated itself. Now, Claude, in the process of building these apps, it will certainly produce code in order to run and execute these models, but we won't need to worry so very much about that code. Our focus instead will be on just what are the features and capabilities of the dashboards that we create. Now, if you were a student of mine and you were learning a little bit about data science, there is no single textbook about how to do data science effectively. Certainly, you can get textbooks on how to code Python or any other programming language, but data science as a process really is governed by lots of best practices. And the same is certainly true, I think, for working with AIs to carry out data science investigations. If we were learning to code, I would teach you how to read data from a file, how to refine that data, how to build in-memory data structures, and ultimately produce, hopefully, some sort of insightful visualization. And this is an iterative process. Coding for data science often involves refining and exploring your data interactively in a way that ultimately we hope will lead to some deeper insights about the data. And similarly, although we're not explicitly coding when we work with Claude, nevertheless, I think it can be helpful to be guided by certain workflows, certain recipes that I have found in my own experiments seem to work quite well. And the way that I recommend for all of you to approach the problem of building interactive dashboards and data-driven systems with Claude is to maybe start by creating a project. And we'll start with selecting specifically a research project, because this seems to provide a basis then for kind of consolidating all of our reference materials, including our data. And from that, we can then proceed to build our application. But the way that I do this, I select projects. I specifically ask to create a research project. Claude will ask you for the name of your project. You create the project, and the first thing it asks you to do is upload reference materials. In our context, that reference material is the data that we want to work with. And Claude will support a variety of different formats, including CSV tabular data, text files. JSON is a data interchange format used in web services, and of course, Excel spreadsheets. And once you have that data loaded, then you're ready to begin the process of asking Claude to generate for you a dashboard and a visualization. And once you do that, once you enter your request, then what you will see is it responding by telling you that it's analyzing your data and processing it, and you'll see like hundreds of lines of code being generated on the side. Now, you don't necessarily need to worry about the details of that code. If you are a software developer, great, you could examine it closely and maybe use that investigation of the actual lines of code to debug that code, but there's no actual requirement if you're just a novice programmer or no programmer at all. You can still see the code being generated, but our main interest is seeing what happens at the end when it's finally completed generating that code, and it will then produce maybe a good visualization for us. Now, be aware, this is inevitable that sometimes some things might go wrong. In the process of generating code, AI sometimes makes mistakes, and it may produce buggy code, or it could produce results that run, but nevertheless fail to produce an output that meets your expectation. And if that happens, my advice to you all is don't panic. Very often, if it's some sort of a syntactical problem with the code where it simply won't run, often Claude will give you the option to try to fix that code, and it will do the debugging and the repair for you. And then our hope is that after perhaps 1 or 2 rounds of refining the code, it will produce some sort of a visualization. And here is an example visualization. This is not necessarily the endpoint of what it is we're trying to achieve. Instead, it may be a first draft. And just as I tell my students who are learning to build visualizations, writing Python, you still have to go through a kind of iterative process, explaining to Claude what needs to be changed, what needs to be fixed. There may be aesthetic changes to the visualization that could improve it. There may be functional enhancements that you want to add. But it's all done by simply prompting repeatedly and getting it ultimately to do what you want. It can take a few rounds to really produce the final endpoint. Okay, so stand back. We're going to try to do a little bit of science here. I did pick all of my examples from the world of biology and biomedical science and astronomy. So here are the several use cases that we're going to explore this evening. The first involves a really fascinating data set involving a record of when the cherry blossoms in Kyoto, Japan come to full bloom. And remarkably, this data is available going back 1,200 years and can reveal some insights about the nature of climate change. We'll also study the connections between genes and diseases and what implications this has for the development of personalized medicine. And then finally, as my last example, I wanted to do something a little bit different. So the first 2 examples involve feeding Claude some data and having it build a dashboard to explore that data. But it also turns out that you can use Claude to build models and simulations. And we can use this, for example, to build a simulation of the solar system and to predict how, as Galileo observed in the early 1600s, how this would affect the appearance of Venus through a telescope. So we'll give that a shot as well. Let's start with the cherry blossoms of Kyoto. Fascinating data set. Several years ago, there was a story that came out of a newspaper in Japan mentioning that this data had been collected by Osaka University. And interestingly, the cherry blossoms in Kyoto had peaked earlier in the year than ever before. It was a record going back 1,200 years. And when I saw this article, I was like, stunned very much for the fact that, well, you know, who has 1,200 years of data going back? Well, ancient civilizations do, of course. And so I got curious about this data set and what it might suggest for the study of the warming Earth and climate change. And you can also obtain this data from NOAA and the National Center for Environmental Information. The spreadsheets that contain all of this data are readily available. And if you open up that spreadsheet, you will see it is just a spreadsheet with much annotations and citations to explain the source of material for all of this data. But the critical information is simply 2 columns, one recording the year and the second the day of the year on which the cherry blossoms in Kyoto came to full bloom. So for example, this is showing that in 1757, it was on day 112 that the cherry blossoms came to full bloom in Kyoto. And the question is now, how has that changed, or has that changed? And are there implicit trends in the data that we could examine? So I want to mention before I show you the result of doing this analysis with Claude that this is part of the broader science of phenology. This is the science of periodic changes in the natural world, particularly as impacted by the climate and climate change. And this can cover everything from, you know, fall foliage in New England to the timing of when birds lay their eggs or when insects will emerge from a larval stage. And so the question now arises, if the change of the blooming patterns of cherry blossoms in Kyoto is changing over time, is this a marker perhaps of climate change? Now, I do want to also mention phenology is a science, it's a scientific study, not to be confused with phrenology, which was the debunked pseudoscientific practice of predicting individual characteristics based on bumps on your head or other external characteristics. No, we're not talking about phrenology. This is about the scientific study of phenology. And having a spreadsheet in hand, perhaps you're adept at using Office applications like word processors and spreadsheets, you might be inclined to open up that data in the spreadsheet and use built-in menus to create your visualization. And frankly, as a data scientist, I kind of find this simply not good enough, because although you can customize this, it's really, I think, challenging to build insightful and beautiful visualizations using spreadsheets. They're not really designed for in-depth scientific analysis. These are clearly just not publication-ready visualizations. But I did have something in mind, which is maybe something a little more like this. Now, this is the kind of visualization that first-year students in Python programming might be able to produce, right? It doesn't necessarily involve advanced techniques, but in your first few weeks of learning to code, you might develop a facility with parsing data, using built-in Python libraries to generate scatter plots, even the algorithms necessary to generate a moving average trend line, as I've shown here. And this, I think you would agree, is a little bit more aesthetically pleasing. It is static in the sense that there's no way for me to interact with the resulting visualization, but clearly it provides a little bit more insight than what we had here. But unfortunately, it does require now a bit of coding to do this. And this particular visualization, using just basic Python techniques, was probably about 100 lines of code. But again, something that you would learn to do if you wanted to take a course in Python programming and introductory data science. Now, we could go beyond these sorts of static visualizations and think about, can we build interactive tools that allow us to filter and visualize the data in more exploratory types of ways. And this is really now, again, something you could do in Python. And now we're really talking about advanced visualizations that require perhaps a year or two at least of experience in software development. You can certainly create highly customized and beautiful dashboards, and these particular dashboards that I'm showing here are the result of work that I've done in collaboration with undergraduate students of my advanced programming with data courses, leading to presentations and posters at Northeastern's RISE conference. But again, as you build more sophisticated types of visualizations and begin to try to implement interactive elements, inevitably you're talking about requiring more training, more technical expertise, more time to get to that level of competency with software engineering and data science. So we have this fundamental trade-off in working with data. On the one hand, spreadsheets, most people are at least somewhat technical literate so that they have experience perhaps with using spreadsheets in an office environment. And they know that, yes, you can create simple bar charts and line plots in a spreadsheet by following the right set of menu commands. As soon as you start to really try to build increasingly functional visualizations that are perhaps more interactive and ultimately more insightful about your data, then now you're really getting into the world of software engineering and data science best practices and ultimately writing code. So wouldn't it be nice if somehow we could get to this part of the graph where we have something that's easy to use, but at the same time can achieve a certain degree of functionality and insightfulness and interactivity to explore that data in a more meaningful way. So that's what I'm going to show you what I did here. So let's move on over to Claude. And what I'm going to do is, rather than run the building of the application entirely from scratch, because every time we do a refinement, it can take a minute or two to generate that code, I'm just going to walk you through a couple of case studies where I step you through the various prompts that I created to ultimately construct this visualization. So we're working with cherry blossom data, and in doing that, I created a project, I uploaded some data, and for this particular example, I had in mind a particular visualization that I was aiming for. Now, it's not necessary to be this detailed when you're first starting out, but because in this particular example, I knew exactly what I wanted, I chose to give Claude some specific instructions. And I explained to Claude, I've uploaded a data set. I gave it some context saying this is data representing the day of the year when cherry blossoms come to full bloom in Kyoto, Japan. And that I want to create an interactive visualization that allows me to select a year range that allows me to overlay a moving average and to control the window size of that moving average. So just FYI, if you're not familiar with that concept, that simply means that we're imagining looking at segments of data in a moving window, and we're computing the average of the data points that fall within that window. If I make the window very large, that's going to smooth the data even more and allow me to identify very broad trends. If I have a small window size for my moving average, that's going to adhere more to the fluctuations of the data in the short term. And I even told it, please plot the data in cherry blossom pink and put the moving average with a thick blue line. and maybe include a toggle switch to control the y-axis labels. Okay, so I'm being very specific about what I want. This is one approach. Another approach, which I'll show you in the next example, we're just going to let it do its thing and let it be creative and see what it comes up with. Now, when I did this, gave it these instructions, this is the visualization that it came up with. Okay, pretty close to what I was looking for, actually. Now, I start to look at this critically, and I notice a couple of things. Number one is that maybe my axis labels are a little bit cluttered there. That should probably be improved. This isn't entirely publication ready yet. I think the connecting of the dots or of the data points is adding some unnecessary clutter. And oh, by the way, my range slider isn't quite functional. And so there are some mistakes. It did run, but it produced some errors. And now the negotiation really begins. And we begin to ask Claude to make some aesthetic improvements, to fix the toggle switches, to fix the axis labels, and so on, to remove the line connections. And then ultimately, let's see what happened here. So with version 3, we made definitely some improvements. Now, at least the sliders are working. And we can specify sort of a range of dates. We still have our moving average being controlled by a nice little slider. There's still some aesthetic issues. My toggle switch is changing the y-axis from the day of the year to an actual date. That's kind of handy, but again, the labels are interfering a little bit, and there's some aesthetic issues. Now, ultimately, when we did this, and just give me 1 second because my my controls are interfering with what I'm seeing. Here we go. After numerous small refinements, again, me simply describing to Claude what I'm looking for, eventually it came up with a what I think is a very beautiful visualization that that's fully functional. I can specify ranges, and the window averages or the moving average window size now works very well, and my labels aren't interfering with each other, and I'm pretty much done at this point. But that's really just the beginning of data exploration, isn't it? I mean, this is now we've built a tool to explore the data. And one of the wonderful things about working with Claude in this way is not just the endpoint of the dashboard itself, it's also the ability to talk to Claude, to ask it for what insights it's seeing out of this data. And why is this data so very important? And so if I scroll down a little bit, you'll see, for example, that let's see, where was it? I asked it about, for example, some of the historical patterns that are embedded within the data, some of the environmental significance of the data itself. In particular, it's noting the fact that the reason we should care about cherry blossoms in Kyoto blooming earlier and earlier is not simply that it may affect our travel plans if we want to be a tourist and see the cherry blossoms, but more significantly, for a warming Earth, these climatological changes can have impacts on food webs, on the stability of ecosystems involving both plants and insects and other animals, and so on. And so using Claude to kind of help us understand the significance of the data and to explore it and talk to be able to talk to Claude about the significance of this data, I think is quite compelling. Now, I did do, it looks like, about 27 iterations. Each time I did this, I was requesting very small changes. I would say over about a half hour to an hour, I ultimately constructed this interactive dashboard. and got it into a state where I really like what I have, and now I'm finished. And it would have easily have taken me much more than an hour to implement this code by hand, even using advanced Python programming techniques. Okay, so that was demonstration number one. Now, for the next demonstration, I'd like to kind of show you a fascinating data set involving connections between genes and gene variants and diseases. And in this particular case, what I'm going to do is be very open-ended and just say, Claude, produce something for me. I don't exactly know what I want. I don't have in mind a particular visualization, but you can still get Claude to produce something interesting, even with very little guidance. So why am I interested in this data set? Since the sequencing of the Human Genome Project in around 2000, when they finally came up with a draft sequence of the human genome after many years of effort and billions of dollars, there was an explosion of biomedical research looking at gene variants and their connection or association with various diseases. So it turns out that many diseases are affected by many different genes. Some diseases may be influenced by a variant in a single gene, but many diseases are multigenic in nature. There's many contributing factors that may not necessarily cause the disease, but may increase the risk of that disease. And similarly, many genes are associated with lots of different diseases. So it's not like a one-to-one relationship. Now, I would like to explore that kind of network of connections between genes and diseases. So why? Because this is ultimately perhaps the basis for an emerging trend in bioinformatics and biomedical science towards customized treatments that are impacted or selected based on your particular genetic makeup. It may be that the right treatment for one person may not be the right treatment for another, and deciding what is the best treatment for you and what treatment is the most efficacious really depends on your particular genetic makeup. So beginning to understand the relationship between genes and diseases can offer profound insights into the nature of our genome. And there is this beautiful data set. It's actually somewhat old and no longer being updated, but it's still a valuable data set. It basically cataloged all of the publications about reported associations and linkages between genes and diseases. And this data set was known as GAD, the Genetic Association Database. It's more than 20 years old at this point and hasn't been updated in the last 10 years. Nowadays, there's other data sets that are more comprehensive and have millions upon millions of records showcasing the connections between genes and particular diseases. But for example, this data set would say that asthma, which is an immune condition or part of the immune disease class, is associated or linked in some way to the gene CTLA4, which lives on chromosome 2. And the database cataloged 3 publications reporting a positive association between CTLA4 and asthma. And they're just record after record, counting up the number of publications that report a positive association. Altogether, this data set has something like 7,000, maybe upwards of 8,000 records. And what can we derive from looking at all of this data in aggregate? That is the question. So in this case, what I did was I basically asked Claude to take this data and build me a dashboard. And in this case, I didn't really know what it was that I wanted out of the dashboard. So I was very open-ended. I just said, create a dashboard for the attached data drawn from the Genetic Association Database, GAD. And I did give it some hints as to what this data is all about so that it could provide some context. And I think this definitely improves the chances that you're going to get something meaningful out of the data. But notice I didn't specify what I wanted the visualizations to look like or what interactive features I wanted to add. I simply said, here's the data, have at it. So let's have a look at that example and see what we got. And here it is here. We'll close this last example and go back to our project list. And here it is. Gene disease connections. Okay, and here's the chat that I saved as part of this project. I'm going to scroll all the way back up to the top. And so there's the prompt, give me a dashboard. It's up to Claude to come up with something. Now, the first time I did this, here was a case where it generated a syntax error. No need to panic. There was a little button that said fix with Claude, and in fact, I did just that. And the second version now worked perfectly well. So here it is. I'm going to just make this a little bit wider so that we can see what we've got here. Okay, so it's basically cataloging for me in a kind of pie chart all of the different publications and how they're distributed across the different disease classes. Over 19% of the records are for diseases or phenotypes related to the immune class and metabolic and so on. And it lists some of the top gene disease associations. So for example, APOE is a known marker for risk factors for Alzheimer's disease. And in fact, the GAD dataset included 66 publications about that association. We can identify also, if I scroll down here, genes that are frequently associated with many different diseases. All right, so this is giving me some interesting overviews about the most frequently analyzed and investigated genes, the most frequently investigated diseases. Within this particular data set, we can look at the chromosome distribution of the genes that have been the focus of study. All right, so this is, I think, a pretty good start. Now, scroll down a little more, and now I start to get a little bit curious. And I said I like to give Claude positive reinforcement, positive feedback. So I said, this is great. But what I'd really like now is to add a tab. Now I'm adding some functionality to this dashboard. And what I wanted it to be able to do was allow me to select a particular disease or phenotype, and then to identify up to 5 to 10 other diseases that have overlapping gene associations. Now, why would I want to do that? And as I said, many genes are involved in multiple diseases. And if we took, for example, asthma, we would find that there are dozens of genes associated with asthma. Could we identify other diseases that are also linked to asthma-linked genes? In other words, could we find genes that these two diseases have in common? And why would we care about such a thing? Well, it may suggest common molecular mechanisms underlying the function or biological pathways that drive the occurrence of both of these diseases. Perhaps a drug or a treatment option for one disease might therefore be relevant to another disease. So this was a request that I was making for added functionality. And here we go. This is the result of producing that request. Now, as I submitted this request, again, you see data or code flying by the screen, and it producing lots and lots of code, making edits, And here is the tab that I asked for. And it is telling me that for asthma, which was my default selection, it turns out that diabetes, according to the GAD data, has 18 overlapping genes. And that's interesting, right? Because now it suggests that maybe those who are at risk of asthma might also be at risk for diabetes. And that although these conditions may appear to be somewhat distinct, in fact, it's their shared genetic overlap that might suggest an interesting connection. And in fact, we asked Claude to investigate the literature, do a search, and come up with citations that might indeed suggest a connection between asthma and type 1 diabetes. And it gave me back several references, including this one. This is an older paper from, I think, 2018. And again, it talks about the connections between asthma and type 1 diabetes in a Finnish population of children. Okay, so you probably didn't expect to be doing biomedical research when you came here this evening, but notice that when we have these interactive tools, we can begin to engage with the data more effectively and begin to gain insight and help us learn these interesting topics. Okay, one last demonstration I'd like to do, and this involves predicting the phases of Venus. So as I mentioned, I live here in Flagstaff, Arizona, which is home to the Lowell Observatory. The Lowell Observatory was founded by Percival Lowell in the late 1800s. He was famous for mapping out imaginary canals, believing that there was some intelligent civilization trying to bring water from the polar ice caps to the desert equatorial regions. And he completely hallucinated the whole thing. But nevertheless, he was kind of the Carl Sagan of his day in promoting astronomy research. The Lowell Observatory is also where Clyde Tombaugh, at the very young age of only 24, discovered Pluto. Okay, so turns out I volunteer at the Lowell Observatory, and I spend occasional evenings standing in front of a telescope and showing kids and adults the stars and planets and whatnot. And up until about mid-March, you may have noticed Venus was very bright in the western horizon. And when people look at Venus through a telescope, they are shocked, usually shocked, to discover that Venus looks somewhat like the moon in that it shows phases. And I then start waving my arms, trying to explain to them, well, you have to imagine as Venus comes around in its orbit and eventually catches up with the Earth, it will become more and more crescent-shaped because it will fall between the Earth and the sun, and we'll be mostly looking at the nighttime side. And so, no, it's not the moon that you're looking at. No, the Earth is not casting a shadow on Venus. And there's no connection to the seasons of the Earth. This is just how the planets align. Okay, so I was interested in using Claude for something completely unrelated to analyzing data per se, but it got me to thinking. What I asked Claude to do was to generate a plot for me to help me explain the phases of Venus. And I simply said, give me a plot of the phase of Venus as a function of time. I was expecting it to produce a little plot, line plot, where time is your x-axis and the phase would go from 0 to 100%, depending on the phase of Venus. And when I did this, I was a little surprised at what I got. So notice that it's creating a kind of model of the solar system. There's some aesthetic problems with this, and it may be hard to see the planets, but let me just minimize this a little bit. There we go. Make it a little bit bigger. Okay. And so what you can do here is you can kind of move the days widget here, and you'll see the planets moving. And as it does so, the phases change, right? The phase of Venus changes. Now, there's a bunch of problems with this, aside from the fact that it's kind of hard to see these little dots. But also, you may notice that Venus, this is supposed to be Venus, isn't actually following along its drawn orbit, and so on. Okay, so again, I began the process of interacting with Claude, telling it to fix this or fix that. One interesting thing that occurred was I was having trouble getting Venus to line up on its orbit. And so what I did was I gave a little screenshot of Venus to Claude and said, this is the problem that I'm seeing. And I have found, and I'm going to let the Anthropic folks speak to this, but I have found that when you actually show Claude the problem that you're having, it often seems to resolve the issue a bit more quickly. And as soon as I did this, then it actually began to work nicely. And so I'm going to just show you the final version of this. Let's see, I believe it's, let me find it. It's about down here. Here it is. Okay, so this is the final simulation. And I want to just show you this. It's quite beautiful. So among other things, the planets are now going around the sun in the right direction as viewed from the north, where north is up. So we're looking from above the solar system, and we can now model both Mercury and Venus, and we could see how the phases could change over time, and also how big Venus and Mercury would appear in the eyepiece as we go around and around. And so, for example, here is Venus catching up with the Earth, just as I described to our visitors at the Lowell Observatory. And notice as Venus catches up, the phase percentage, it's becoming more and more crescent shaped. So very nice application. You can build interactive simulations as a learning tool to understand. You could imagine this, for example, in an interactive textbook to really understand and gain an intuitive feel for astronomy. Okay, so parting thoughts. And where does Claude land on this graph? Well, this is just my opinion, but I would put it probably about here, which is to say it's very hard to beat just talking to an AI to get it to write code. What could possibly be easier? On the other hand, I would say that if I'm really doing research grade data science and I need to create really advanced visualizations, I may still need to learn some coding skills, but you can do an awful lot with some very simple interfaces using Claude. And that, to me, is remarkable and astonishing. So in summary, I would say Claude AI is very good at parsing and analyzing diverse data sets, including things like spreadsheets and tabular data and text and so on. For interpolating missing data, that cherry blossom data set actually had quite a few missing data points, and Claude was able to handle those quite well. Generating bar charts and time series plots and scatter plots and that sort of thing, it does quite well. And introducing interactive features like sliders, and toggle switches, pull down selectors, having multiple tabs to display and render different visualizations all as part of one screen, does that beautifully. And ultimately, you can talk to Claude and have it help you interpret the data and identify important insights and perspectives. And it is an interactive process. Sometimes you do need to talk to it and ask it to make changes, but usually it handles those quite fine. Now, where Claude AI might struggle, I would say if you're trying to develop really advanced visualizations, I didn't have much luck trying to create graph diagrams or network diagrams, or in a few cases, I tried to overlay data on top of a map of a city and to do geospatial mapping. That I think still needs a little bit of work. If you're working with very voluminous data sets, you may run into some problems. There is a 30 megabyte file upload limit, so do keep that in mind. If your Excel spreadsheet is very complex and has a lot of heavy formatting, that could lead to some issues. Obviously, you need to be as clear and unambiguous with your instructions. And it's not really designed, I think, at this stage to handle very specialized data formats like SQLite databases or data formats that are specific to particular statistical packages and the like. So spreadsheets, CSV files, text files, fine. Once you start getting into more customized or proprietary formats, you may hit into some limits. So here's some of my final general advice for using Claude AI to build a data-driven app. For each dashboard that you want to build, create a research project and upload your data in advance. Give Claude well-structured data with appropriate headers so that it can interpret your data accurately. Be detailed upfront if you know what I want, if you know what you want. That's a good idea because it'll avoid numerous cycles of refinement, but it is okay to let Claude draft the first dashboard and let it be creative. And finally, remember, you may run into problems in the sense that the code may not run, you may have a syntax error, and you might have to fix with Claude to often repair the dashboard, and that's just fine. And finally, a more of a meta piece of advice, don't let AI think for you. AI can make mistakes. You have to retain your sense of critical thinking here and examine your results carefully. And finally, always remember, without data, you're just another person with an opinion. And that's it. All right, thank you all for coming.
Thank you so much, John. I would love to. Yeah, I would love to open it up to some Q&A. And we do have Shannon and Amber here from Anthropic. They've been busy in the chat, but I will bring some of the questions to the surface, and we will start with Jeremy. The thing that this is just a virtual hand because it's been up for a while.
There we go. I was just waiting for that mic to be available. Thank you. A couple of questions that I think may be closely related. In yesterday's AI in Action section, we were introduced to the idea of working memory limits and tokens, and how going beyond that, Claude and other LLMs may be prone to hallucinate. Does when you upload data, is it counting against those token limits? And also, how can we be sure that the visualization is not a hallucination itself and not accurately representing your data?
I'm going to let the Anthropic folks speak to the issue of the token limits. I will say that you may have noticed one of the things that you can do is mouse over individual data points and it will pop up the values. And I often did that just to make sure that, yes, that data point is correct. And I did compare, in the case of the cherry blossom example, I did compare it to my own programming to see, did the trend line look the same when I allowed Claude to do it versus when I did it myself by hand. So I feel confident that it is interpreting and loading the data and processing the data correctly. But at the same time, I sort of embrace this attitude of distrust and verify in everything that we do when it comes to working with generative AI.
Cool. And to chime in on the sizing piece, so I just put into the chat, but Claude for Enterprise, which is what Northeastern is using, has a 500K context window. How to think about that, I can throw in like that roughly, means this many pages of transcripts or documents or whatever it might be. But that's at a per chat level. But let's say you have a project that you've created, like the examples that John showed, Any documents that you're adding in there, you'll see a knowledge base counter of how much you can put in your knowledge base, and those are counting toward that 500K. I'll throw in a link that gives a little more context on this too.
Awesome, thanks.
Thank you, John and Shannon. Next, Meryl.
Yeah, hi. Thank you so much for this, first of all. So I started by trying to test it out on some scholarly articles from JSTOR, and I got like an internal server error. So then I switched gears and decided to test it out on some WNBA data where I was able to download a spreadsheet, and that worked great. And it gave me some really beautiful and interesting visualizations about last year's Minnesota Lynx season. But my frustration is that there's no easy way to download the visualizations. Right? It didn't give me a PDF option. I certainly don't have the skills to like do anything with a TSX file. This is like literally the first time I've ever even heard of a TSX file. And even using like the screen print function isn't working. So like I'm wondering, is that user error on my part, or is this just something that you guys aren't like that you're working on, but it's not quite there yet?
Yeah, I pinged our team during this session because we recently launched the ability for you to download an artifact to a PDF. I'm trying to get clarity on if that's only for certain types of artifacts, because I heard in the chat some people saw that, some people did not. So we will definitely keep you posted there. But the intention more generally is that there's more shareability options with artifacts, which candidly are pretty limited right now. So one thing that we're exploring is what it looks like to be able to take these and put these directly into slides. The PDF thing, having that be unlocked across artifacts, but then I also think for these more interactive components, how that becomes more easily shareable than like, hey, here's a link, pass this around. So more to come on that front. Really good feedback for us.
Yeah, in my case, the shareable link also didn't work. Like it doesn't load the visualization.
Yeah, no,
so I'm not sure why. Like maybe it was the kind of visualizations, but in any case, like super useful. And I guess that like the workaround would be you just screenshot each visualization that you want to incorporate into a slide deck. But yeah, having it be easily downloadable would be awesome.
Yeah,
really useful, like really helpful.
Yeah, I hear you on that one 100%. We will definitely keep you posted. This is something Amber and I are really passionate about too.
Okay, great. Thank you, Meryl. I'm going to go over to our Q&A. When you ask Claude for references, were the sources it provided openly accessible? That's from Jacques Alexis.
Yeah, go for it, John.
So I didn't check that for every reference. I sort of spot checked. I believe you probably, my intuition is that you could probably specifically ask for open source references, but my main interest in checking Claude was not to check whether it was open source or not, but just to check whether the references were actually valid and not simply hallucinated. And that I can confirm worked perfectly fine, at least in that one example that I did.
Great. Okay. Let's see. Will the slides be shared? I don't know. We'd have to ask John that, but the workshop recording will be shared. It will be online at the AI in Action website tomorrow by noon, as well as on our YouTube channel.
I'm happy to share the slides.
Okay, great. All right. Let's see. How can we share the dashboards that Claude creates? That's back to that sharing.
Yeah.
Okay. Can Claude analyze qualitative data as well and then generate a visualization at the end?
Yeah, I chimed in on that. And I know Shauna Amber was trying to chime in. I think she can't get her mic off, maybe. I don't know if it's
okay. Let me
1 minute left. I know we're running out of time. Yeah, I'd be curious what you're trying to do quantitative feedback wise, but the general answer I would give is yes. I would definitely play around and see what type of outputs you get from Claude if you do upload something that's more qualitative than quantitative.
Any other questions?
I see the question on, is the Claude instance secure? One thing to note there is Northeastern and Anthropic, which is Claude's parent, I suppose, are kicking off a partnership, and Northeastern is on the Claude for Enterprise plan, which means a lot of things, higher context window, higher rate limits, but more than anything, a higher and continued focus on security. So anything that you put into Claude, we do not use any of that information to train our models, whether that's the documents or chats that you're having there. It's not a self-contained thing in terms of it's not like hosted outside of the cloud, but it is kind of an isolated space that people within Anthropic aren't accessing or our models.
Deborah. Let's see. Let me make sure. Okay. Amber, you should have your mic on too now. Deborah, you should be okay to unmute.
Right. Thank you. Thank you for that. So my question's actually in the chat. I'm not sure if you saw it. It's about these projects and sort of building a dashboard from a data set. Does the code behind the dashboard, does that become sort of separate from the data set? I'm sort of thinking if you actually wanted to update the data. So you had a standard data set and you wanted to submit a later version, or I had data up until the end of 2024 and now I want to submit up to 2025. Would that dashboard just work, or do you have to rebuild everything from scratch? I don't understand exactly. I mean, it was great examples but how does it work?
Yeah, John, you want to take that one or you want me to?
I'm not sure what the answer is, so I'm going to let you take it.
Cool. Okay. I think it depends where the data is coming from, right? So we recently launched or about to launch a Google integration where if you had that data as live data from Google Sheets and it's flowing in, you would be able to simply prompt Claude, hey, can you update this dashboard or artifact that you've created? We are on the path to build similar integrations with Microsoft Suite products. So that would be if those live in kind of more dynamic places where they're getting updated. But one thing I will call out is the artifact examples that John showed where he was going through those different iterations. What's nice about Claude is those are opening up in kind of a third pane. And you can actually go between versions of artifacts. Yes. Let's say you do something and you're like, not quite right, try again. You can get a new version of that. And those are things that you can refer back to. You could also, if you are keen, dive right into the code, which you can open up as kind of a layer behind the scenes to kind of play around and adapt things if you want to do it that way. You definitely don't need to, though.
Okay, thank you.
Yeah, of course.
John, would you like to go next?
I guess that's me, John Alexis, right?
Yes.
Okay. Yeah, I was asking my question online, and I'm already getting some answers in them by Shannon. Thank you very much. So I was asking about I think I saw that announcement about us getting a special version of Claude. So I guess it's like, how can I ensure that my students are getting that version, that it's supposed to be more Socratic and helping them to arrive to answers instead of just providing the answers? Because like what I have been experiencing is like, it's just working exactly the same way that other instances of Claude. So if you can elaborate a little bit more on that.
Yeah, so we launched when we announced the partnership, we launched what we call learning mode. I linked in what that looks like, that we'll have some screenshots for you of like, I'm wondering exactly what you're seeing or what your students are seeing on their end. The intention with that is that it's giving some more guided steps that are, to your point, intended to be more Socratic in nature, where if a student asks something, Claude will guide it in certain ways. the default is if they're going down one of those paths that are kind of the primary spots on the bottom as their call to action, that will take them through that flow. I think if they're chatting just in the main area, they might be getting the same flow that you would expect from the standard product. So there's likely some, how do we pull some of that into the main part of the chat, but also how do we guide people and the students through the ideal flow that we want them to take.
Great. Okay. Awesome. Well, I am going to be sharing a poll with you all. We are at time. Looks like we've gotten to all of the questions. This first poll is just about AI in action and just your experience there. Stay tuned. On the website, we'll announce more events. I will also be including information on the upcoming Claude trainings that are available at Northeastern. So there'll be a link to that, as well as a Claude dialogue that is included in this next communications. I'll be sending it out. It is here in the chat, but I'll also be sending it out via email for everyone that attended this week's events. We so appreciate our Claude friends being here. Thank you for reinforcing all of the tool and what it has to offer. And thank you, John, so much. This has been
my pleasure.
super informative, and we appreciate you. Thank you, everyone, for coming. Have a wonderful night. Bye-bye.